Okay, let's get into this. AI, it feels like it's just, well, everywhere now, doesn't it?
It really does.
Helping us search, yeah. Editing photos,
Yeah.
popping up in our operating systems, baked into so many websites we use daily. It's so convenient, almost invisible sometimes.
Absolutely. It's become this sort of seamless layer in, our digital lives. You just type, click, and boom, you get something back.
But the sources you shared for this deep dive, they ask this really key question behind all that seeming ease. What's the actual cost, the true cost of running these AI queries?
Yeah, what does it really take?
Economically, infrastructurally, what's powering the AI we're all interacting with?
And that's exactly what we want to do today. Take that material you've gathered and, well, give you a shortcut, really. Help you understand the hidden stuff, the surprising costs, the complexities, and maybe what's coming next, what's really happening behind the curtain.
Okay. So right away, one thing that jumps out from the material is how opaque things are right now. These AI facilities, they're still pretty new, relatively speaking. And companies, they're not exactly shouting their running costs from the rooftops.
Not at all. It's definitely early days, and the exact economics are, let's say, murky. Or maybe they're keeping it close to the chest intentionally.
Right.
But the material does give us some reported ranges for query costs, which is pretty fascinating.
Okay, what are we talking about?
For the simpler AI models, basic stuff, it could be as little as a few dollars per query.
A few dollars. Okay, that sounds manageable, I guess, for some things. But where does it scale up? When does it get pricey?
Yeah, this is where it gets really interesting. For the complex models, right, especially the ones needing specialized top-tier hardware, the cost per query can just skyrocket.
How high?
The range reported, it goes from hundreds up to potentially thousands of dollars.
Thousands for one query.
Per query, yes.
Wow. Okay. So if I ask a really sophisticated AI to generate a minute-long video or, I don't know, write a huge report based on tons of data, that could be hitting that top end.
That's exactly the idea. It's all about how computationally intensive it is, the resources needed for that specific task.
Okay. And that huge difference in cost, from just dollars to potentially thousands, that probably sheds light on something we see everywhere now. Premium subscriptions for AI.
Makes sense, doesn't it?
Yeah. Lots of companies offer these premium tiers. You get faster service, maybe you can generate longer videos, or just use it more often than the free version.
And the sort of suspicion raised in the material is that these subscriptions, they aren't just about adding cool features. They might be a really crucial strategy to try and offset those, considerable development and running costs we're just starting to talk about. It's about making the economics work for them.
So the free tier could be like a loss leader or just very limited while the paid subs are trying to claw back some of that massive investment.
That seems to be the thinking.
Okay, but let's dig into why it's so expensive.
Yeah.
What's the actual physical stuff needed? The infrastructure.
Well, it really boils down to the hardware. Running these large language models, the LLMs everyone talks about, it takes seriously powerful processing.
Like supercomputers.
Kind of. We're talking high-end GPUs, graphics processing units, or even custom-built AI accelerators, specialized chips.
And these aren't the chips you'd find in, say, your gaming PC at home.
Not typically, no. These are industrial scale, designed for the kind of massive parallel processing AI needs, and you need lots of them.
Okay, so where do they put all this gear?
In huge, expensive data centers, really large facilities.
And those data centers, they need more than just floor space, right? They need specialized power grids and, crucially, huge cooling systems.
Exactly right. All those chips working hard generate an incredible amount of heat. Keeping everything from overheating is a massive operational cost in itself.
Which leads us straight to energy consumption. The material actually has some specific numbers here. What's the energy cost for just one query?
Yeah, the estimate is that a single query on something like GPT-4 needs somewhere between 10 and 20 watt-hours of energy.
10 to 20 watt-hours.
Depends on how complex the request is, obviously.
Okay, 10, 20 watt-hours might sound small on its own, but when you think about the millions, maybe billions of queries happening globally every second.
It adds up incredibly fast, exponentially. And that cooling you mentioned.
Yeah. How much energy does that take?
It's a major energy drain. The analysis suggests that depending on the data center's location, the climate, local energy mix, up to 20% of the total energy the center uses can be just for cooling.
20%.
Yeah.
just keep things cool.
Yeah.
So that's a huge slice of the energy pie.
It really is.
And it's not just the energy to run the hardware, is it? The sources mentioned the hardware itself doesn't last forever.
No, it definitely doesn't. Those powerful GPUs, they degrade. Performance drops over time. And the general expectation is they need replacing after about, say, 5 years.
5 years.
Which is another constant rolling cost baked into running these data centers.
5 years for hardware that must cost a fortune individually. And the scale. The numbers mentioned are kind of mind-boggling.
They really are. The materials suggest just one company might be using anywhere from 10,000 to 30,000 GPUs.
10 to 30,000.
Spread across multiple data centers, potentially, just to power one specific LLM. So imagine that 5-year replacement cycle hitting tens of thousands of expensive units all the time.
That's an unbelievable level of ongoing capital investment, just maintaining the setup. And it's really important, as the sources point out, to separate this. Everything we've talked about so far is the cost of running the models, handling our queries day to day.
Right. That's often called the inference cost. But that's completely separate from the cost to actually train a new AI system from scratch.
Which the material calls eye-watering.
Yeah, that's a good description. The example given for training GPT-3 specifically, that single training process was estimated to use just under 1,300 megawatt hours of electricity.
Okay, 1,300 megawatt hours.
Yeah.
How do you even picture that?
Well, the comparison they offer is helpful. It's roughly the same amount of power that about 130 average homes in the U.S. consume in an entire year.
For one training run of one model years ago.
Exactly. And models have only gotten bigger and more complex since then. Imagine training multiple systems, larger systems, maybe retraining them regularly.
Okay. So running costs are high, complex, infrastructure is pricey, needs constant updates, training costs are astronomical. Does the type of thing the AI generates make a difference to the energy use? Like text versus images?
Yes, the research points to a noticeable difference there. LLMs that are mainly spitting out text generally use less energy per query compared to models generating images or videos.
Oh.
Creating multimedia, visual stuff is just significantly more demanding computationally and energetically.
Gotcha. And it feels like this whole field is just moving at lightning speed right now. The material talks about a constant barrage of new systems. Almost weekly, it seems, something new pops up, leapfrogging the last one with better abilities.
Yeah, that rapid evolution must make managing costs incredibly difficult.
It sounds like a massive, continuous investment race. R&D, deployment, everyone's scrambling to build the next big thing, which just fuels costs everywhere.
Definitely.
Which I guess brings us back to that big business question. With all these huge costs, training, running, infrastructure, power, hardware churn, constant R&D, are these companies actually, making money yet?
Well, the suspicion raised in the sources is, for many of them, the answer is probably not clear. Or maybe even no.
Really?
Some companies might not even have a full handle on the total end-to-end costs of the very systems they're building and running right now. It's that complex and fast-moving.
So it's less about turning a profit today and more about the future potential.
That seems to be the perspective presented. Companies view AI as this fundamental future tech, right? A potential massive earner way down the line. So they're investing incredibly heavily now, basically banking on those future revenues to justify today's spending.
It's like a really high-stakes bet. And the comparison the material uses here is pretty stark.
Yeah, it's interesting. They draw a parallel to the early 1980s, the home computer boom.
Okay.
You had this explosion of companies, tons of innovation, everyone jumping in, but ultimately a lot of them didn't make it. They faded away.
Right.
And the prediction is that many of the current AI companies are not going to go the distance either. They'll fade away too.
So this current landscape with maybe hundreds of AI players, it could shrink dramatically, consolidate, like the PC market eventually did.
That's the idea. It's not just an investment race, it's kind of a survival race too.
Wow, okay. And while all this is happening, this rapid development, intense competition, massive spending of material, also notes there isn't really a great deal of regulatory oversight on AI systems yet.
No, the rules are still catching up significantly.
And that lack of existing regulation, I suppose, leaves space for thinking about how things could work differently, like that suggestion about consumer tools.
Right. One really interesting idea floated in the sources is introducing something like Energy Star ratings, but for AI models.
Energy Star, like you see on a fridge or a washing machine.
Exactly like that. The concept is that AI companies could, or maybe should, be transparent about how energy efficient their different models are. And this would let consumers, or maybe businesses choosing AI services, compare different systems based on their energy footprint.
You, the user, could potentially choose a greener AI model if that information was available, similar to picking an efficient appliance.
Precisely. It could create a real incentive for companies to optimize for energy efficiency if customers started demanding it or choosing based on it.
That could actually shift things, give users some power, some awareness, promote more sustainable AI. Interesting.
Yeah, it's a neat idea.
Okay, so let's follow this thread into the future that the material kind of sketches out. Imagine we're years down the road. That initial crazy AI rush has calmed down a bit.
Right. In this future, the market looks different. It's consolidated. Fewer, bigger players left standing. And crucially, the costs of running AI queries are much better understood. Less guesswork.
And maybe the era of free, unlimited-seeming AI is largely over. The sources suggest pretty much everyone will have to pay to use these systems eventually.
Yeah, they outline a few ways that might happen. You might have to watch a load of ads, or pay a subscription like we're already seeing, or maybe some kind of AI pay-as-you-go model where you're billed directly for the processing power you consume.
So it paints this picture where the amazing convenience we have now, often for free, comes with a very clear and probably significant price tag attached down the line.
Yeah. So pulling it all together, what this deep dive into your sources really shows is that the AI we use every day, the stuff that feels so instant and easy, it's built on this, well, enormous and often hidden foundation. Costs related to energy, hardware, infrastructure.
It's a field that's just white hot right now. Intense, rapid development, fueled by huge investments. And many companies are probably not profitable yet.
No, they're banking on a future where AI is indispensable, where the costs are clearer, and where users, like you, might pay for it in various ways.
Understanding these background costs really helps put everything in context, doesn't it? The business models popping up, the scale of the infrastructure being built, why there's so much money pouring into this.
Absolutely. It provides that crucial context.
And finally, the sources leave you, the listener, with this really provocative question to chew on. Something to think about as AI gets even more embedded in everything. We've seen big shifts in global industry before, right? Like when developed countries became the main places making most physical goods. So looking ahead to a time when AI processing costs are well known and maybe still quite high, could we see a situation where parts of the world without these giant power-hungry AI data centers start, well, installing humans to do certain jobs instead?
Because human labor for some specific tasks might actually become the cheaper or more efficient alternative again.
Exactly. It's a kind of wild thought, isn't it?
Yeah.
But the sources raise it based purely on the potential economics. Definitely some food for thought there.
And for you, dear listener, keep exploring, keep questioning, and keep the conversation going. Thanks for joining us on this deep dive.